Hello guys, this is NP Chan. Welcome to my mathematics class. Let's see the today's topic. Today's topic is combination, but main topic is some useful results on combination. Today we will discuss the some very important useful results of combinations. Right? I've taken here five very important results on combination. If you know these all results, then very easily we can tackle the questions on combinations. All right. One video already I have made on combination that was on theorem. On the theorem of combination of an objects taken are at the same time is given by, see what was the theorem in last video. uh, Combination of n objects taken r at a time is given by n factorial upon n minus r factorial. So this is the important theorem, right? This is your important theorem. Now using this theorem, we will try to prove the prove the very important results, right? On combinations. So once again, C of n r is equal to, or you may write down like this way also, NCR n factorial upon n minus r factorial. Okay, now let's start the proof of first property or a first useful result. Proof here, this is your left hand side and this one is your right hand side. Okay, now I'm going to take the right hand side. Right hand side, your right hand side is equal to C of n comma n minus r, or you can say n c n minus r. Okay, now let's apply this theorem. Okay, combination of n objects taken r at a time, at the same time. Okay, at a time n factorial upon n minus r. So here r is this one. R is n minus r. Okay, n minus r. So okay, so I'm going to explain in details. Then r factorial. R is means n minus r factorial. Okay, n factorial upon n minus n. When we open the bracket, this negative sign will change, as you know, plus factorial, sorry, n minus r factorial. And here you will get n cancelled, n factorial upon, here again I forgot to write down, r factorial, n minus r factorial. You will get n factorial upon n minus r factorial is equal to your left hand side. Okay, so you can say not here left hand side, here you can, this is of NCR is equal to left hand side. Okay, now we have proved, okay, right hand side is equal to left hand side. So in very simple way, right? Just you have to use this theorem. All right, so theorem done, first property done using, okay, basic theorem. So first useful result we have done. Now you understood. And so here all result, one more thing let me write down, okay, here. So these all result, okay, CTM, right? CTM means, okay, committed to memory. You have to memorize all results. Okay, now let's move into the proof of second theorem. Sorry, second result. Let's move into the second very useful result. We have here proof C of n comma r is equal to C of n comma n minus, no, here r factorial, second one, this one. Sorry, here proof of second result. Here we have given this one. This is a given part. This one is a given part, and we want to prove okay this result. All right, we want to prove this. See here, we have C of n comma r, and CR is equal to NCR prime implies, right, here n equal, and here both combinations are equal, so definitely okay r must be equal to r prime, so r is equal to r prime. Also one result be proved, and also C of n comma r is equal to C of n comma r prime implies C of n comma r is equal to C of n comma n minus r prime. How can we write down this? Using first result, okay? Using first result. According to this, we can write down, if we have NCR, we can write down, okay, is equal to NC and minus R. Using this, I have written here. So, implies n is equal to n, same here, n same, and okay, this combination is equal to this combination, then definitely okay r must be equal to n minus r prime. Implies you can write r plus r prime is equal to n. Okay, so therefore we can say C of n comma r is equal to C of n comma r prime. If you have this one, you can write down, then implies either your r is equal to r prime, or r plus r prime is equal to n. So one result you may get from here, right? Either you will have this one or this one. Okay? Now clear second result also. So memorize this one also. Okay, so hence the proof. Any more problem? No, here I don't so think, right? So if no problem, then we are ready to move in. Okay? Let's see the property 3. Proof. Let's see the statement of the third result third. N and R are natural numbers officially here, such that R lies between 1 and n, right? Okay. Then we have to prove NCR plus NCR minus 1 is equal to n plus 1 CR. Okay. So let's take left hand side. So what is the left hand side? Very important result we use in proving the theorem of binomial also. C of n comma r minus 1 is equal to, okay, just as we know, okay, C of n comma r is equal to n factorial upon factorial of n minus r into r factorial. Okay, using this result, using this theorem, let's move n factorial upon n minus r factorial, and plus here n factorial upon, see very carefully, very important one, n minus r plus 1, n minus r this one factorial, and r minus 1 factorial. Now see here, n factorial, in numerator we have seen. There is no problem, n factorial, we can take common. And now here, 1 is n minus 1, n minus, see very carefully, n minus r factorial. Here n minus r plus 1 factorial. Okay? And so this one is greater, n minus r plus 1 is greater than n minus r. Like this, we suppose if n minus r is 5, then n minus r plus 1 is your 6. Okay, they are in the same, okay, right, pattern. So we will always, okay, we will expand, okay, greater one. Why we will expand, okay, greater one? If we expand, okay, greater one, 6 times 5 factorial, you may get, okay, 5 factorial, right? So thereafter it will be easy to take common. Okay, so let's see here. Uh, n factorial upon n minus r factorial. Okay, r factorial. And one more thing, let me tell you. Here is r factorial and r minus 1 factorial. Which one is greater? R is greater, right? So we will expand this one, right? This one, and here you will not expand this. Here, okay. N minus r plus 1. Okay, this one is greater than this. You will expand this one. Always, okay, expand greater one. R here you can write down r minus 1 factorial plus here n factorial same, and here n minus r plus 1, and you will get n minus r factorial. You will stop here because n minus r factorial is here, and we are not going to expand this one. Okay. Now we can n factorial common, and n minus r factorial, n minus r factorial common, and one more thing, which one is common? uh, here r minus 1, so r minus 1 r minus 1 factorial is also common. Okay, now this n upon this is your common. Inside the bracket you will get here 1 upon here r plus here you will get 1 upon n minus r plus 1. Now we will take LCM. Here n factorial upon n minus r means, okay, factorial, okay, factorial of r minus 1, and here you will get, okay, n minus r plus 1 and plus r over r n minus r plus 1, and r cancel. Okay, all right, you will get here n, simply n plus 1 you got here. Write down, okay, n plus 1 n factorial. Okay, now here n minus r plus 1, this one is greater, so write down, okay, greater one here, n minus r plus 1, and then n minus r factorial. Now r minus r is greater than r minus 1, so r minus 1 factorial. Why we have written? Okay, now you will understand here. Suppose if we have a 6 factorial, then you can write 6 times 5 factorial. If you need, okay, you can expand up to here. So 5 factorial, 6 times 5 factorial, we can write down 6 factorial. If we have a, suppose, okay, 7 times 8, okay, yeah, let me write down, okay, here 8 times 7 factorial, you can write down 8 factorial. Okay, so same, using, okay, same trick, same method, we will write, okay, we can write down here. So n plus 1, n and n plus 1 conjugative numbers, n plus 1 is greater than n, so we can write down here n plus 1 factorial. Okay, and here what you can write down? N minus r plus 1, here n minus r, so we can write down n minus r plus 1 factorial, and here we can write down r minus 1 factorial. Okay, so we have done. Now all right, if you can find out from here, if you can, okay, convert, okay, this in terms, okay, in terms of this, then all right, if you are unable, then we can write down, okay, in a form r minus, sorry, here r minus 1 factorial, not here. R minus 1 means r factorial, r is greater than. And see, this one we can write down, what we can write down here? N plus 1 factorial, c of n plus 1 comma r factorial. So one more thing, okay, let me write down, okay, let me make it easy for you. Okay, so you will write down like this way, n plus 1 factorial over, here you can write down n plus 1 minus r factorial, r factorial. Now you can understand, n plus 1, n plus 1, okay, here n plus 1, here also n plus 1, this is r, here is r. Alright, now we can write down, here I am writing, so we can write down now c of n plus 1 comma r, alright, which is your right hand side. This way we can prove. Okay, now I also think you have a problem. Now you understood. Okay, And similarly, this done, and similarly you can prove this one. Same method you will apply, right? For 4 also. And now 5, let me tell you 5, although you can do, I think, okay, let me tell you 5 also. Left hand side C of n comma r over C of n comma r minus 1. So what we can write, just you have to expand. You have to, eventually you have to use theorem n factorial, okay, over n minus r factorial whole upon n factorial over n minus r plus 1 factorial, and here r minus 1 factorial. No problem here, is equal to n factorial over n minus r factorial times, okay, n minus r plus 1 factorial, and here r minus 1 factorial over n factorial. Okay. Mm, these two will be cancelled out. Now you have to just expand greater one, right? So n minus r plus 1, this one is greater 1, r minus 1 factorial, here this is r factorial, and r is greater 1, right? So we will expand, okay, this one and this one, right? Okay, n minus r plus 1, here we can write down, what we can write down, n minus r factor. You can stop here, okay, n minus r factor, and times your r minus 1 factorial over n minus r factorial, r you can write down r into r minus 1 factorial. So simple now, okay, cancel, okay, and here cancel, you are going to get your final line n minus r plus 1, n minus r plus 1 over r, okay, which is your right hand side. So like this way we can prove. You have to memorize this result also. Okay. So what you can write on directly, if you have a C of n comma r over C of n comma r minus 1, you can write n minus r plus 1 over r. Right? What you can write down? N minus r plus 1 over r. Right? So this way you can memorize. Right? So these all, okay, these all are useful results on combinations. If you know all these, including the theorem, then you can handle the practical questions very easily. So definitely, I'm pretty sure you will not have any problem. Okay. So if you have still any problem, if you could not understand any line of in today's video, you can write down in comment box. And if you like them, if you are newcomer, subscribe, and like, share, do each and everything to promote this video. Okay. Thank you very much for watching. Bye bye.